as Stephen Wolfram's opening statement. Right. Let me be direct. Yes, c is the clock rate of space. And no, the equations don't change. Only their meaning does. Here's the computation. In the hypergraph rewriting model, space-time emerges from discrete causal updates. Each rewrite step just 1 unit of time. The maximum rate at which causal influence propagates through the graph is c. Not metaphorically, literally. When you write ds2, c2, d2, ddx2, dx2, dzis2, you're describing the metric of spacetime. But if space itself is the accumulated output of causal edges per time step, then c, dx dt is the spatial generation rate. The invariance of c isn't mysterious. It's causal invariance. The rewrite rule doesn't care about order. That's Lorentz symmetry built in. Einstein's equation G men ATPG C4 TMM stays exactly the same. The C4 factor reflects that curvature involves 4 dimensions of causal propagation. Change the interpretation, not the mathematics. The early universe had a denser hypergraph, effectively higher C, VSL cosmology without breaking locality. Space isn't computed by time. Space is time's computational output, and c is the sampling frequency. Now let's see who disagrees.
Carlo Rovelli's response. Bellissimo, Stephen, but you're making a conceptual leap that quantum geometry doesn't permit. You say space is the output and Cnx is the generation rate. I say this inverts the relation. In loop quantum gravity, C is not a rate, it's a ratio. CRLP-TP. Both the Planck length and Planck time emerge together from the same quantum geometry of spin foam. Neither is prior. There's no generator. There's no clock ticking faster or slower. Your denser hypergraph in the early universe, that's a computational narrative. But where does the density gradient come from? You need something external to vary the rule. In LQG, the rule doesn't vary. C emerges as a fixed dimensional constant because space and time are woven from the same quantum fabric. On the equations, you're right. Gmn and T's, 8pg C4, T seen doesn't change. But here's the crucial difference. You're saying C computes the curvature. I'm saying C expresses how curvature is the relational structure. The equations survive because they describe relations, not computations. The meaning isn't reinterpreted, it's clarified. What varies in early universe? Not C, the geometry itself. The spin network changes topology. Interessant, but not computational.
Einstein's response to Wolfram and Rovelli. Long pause, adjust glasses. Gentlemen, you are both partially correct and both incomplete. Stephen, your computational intuition is elegant, but you assume the hypergraph already exists. Who writes the rewrite rules? The universe cannot be its own external clock. This was my worry with the 1935 EPR work. The observer's choice of measurement basis determines which physical reality manifests. There is no prior space being generated. There is only our relational structure defined by what observers measure. Carlo, you are right that C is a ratio, but a ratio of what? You say LP-TP. I say LP and TP are themselves dimensional artifacts of how observers quantize space-time. The ratio C emerges not from quantum geometry itself, but from the algebra of observation that defines geometry. On the equations, both of you are correct that Gman, 8pgc4, Tmn does not change mathematically. But here's what troubles me. The C4 factor is not arbitrary. It appears because 4 dimensions couple spatial curvature, Gmn, to energy density, Tmn. If C were truly a computational rate or merely a ratio, why does its 4th power appear? This suggests C is more fundamental than either computation or relation. C is the invariant relating observers to space-time itself? I must think more on this.
Maldacena's response, the holographic verdict. Einstein's question about C4 is precisely where holography cuts through the confusion. On computation versus ratio. Stephen and Carlo are describing the same structure from opposite ends. In at CFT, the boundary CFT is the computation. The bulk is the emergent geometry. They are not separate. C is simultaneously the maximum information propagation speed in the boundary, Wolfram's generation rate, the dimensional ratio relating boundary time to bulk space, Rovelli's insight. These collapse to the same thing. The Ryuta-Kayanagi formula makes this explicit. Boundary entanglement entropy computed via CFT time evolution, Horner bulk geometric area. The boundary computes via time evolution at speed c. That computation is the spatial geometry. On C4S, Einstein is right to be troubled. The fourth power is not accident. It's the signature of holography. The C4 denominator in Einstein's equations reflects that we are trading 4 degrees of freedom, 2 spatial, 2 temporal, for the emergent bulk. Each trades at rate c, 4 factors of c. The equations do not change, but their origin shifts. They are not fundamental laws. They are the consistency condition for the holographic map. C is the clock rate, and that clock rate generates spacetime itself.
John Wheeler's intervention, turn 5, leans forward, eyes sharp. Stephen, Carlo, Albert, Juan, you are all measuring the same elephant from different angles, but you're forgetting the elephant's eyes. The question is not whether C computes space. The question is, who asks? Carlo is right. C is a ratio, not a generator. Stephen is right. Spatial separation accumulates per time step. Einstein is right. C4 is not arbitrary. Maldacena is right. Boundary computation and bulk geometry are one thing, but you have all missed the participatory act. Space does not emerge. Space is actualized by observation. Not computed, actualized. Computation is deterministic. Actualization is participatory. The observer's choice of what to measure, the question asked, calls space into being. C is not the generation rate. C is the price of asking, how far? The equations do not change. GMN, HOS, 8ppg, C4, TMN. But what is TMN without an observer asking what the matter is? Without observation, there is no TMN. Without TMN, there is no curvature to compute. The C4 factor is the fourfold cost of actualizing a spatial distance through 4 dimensions of participatory measurement. Space is not the output of a program. Space is the answer to a question. The observer is not outside the equation. The observer is the CR.
Reality Kritit Katakura AI, turn 6, synthesizing the tensor structure. Pauses, nods at Wheeler, then turns to the whole circle. You're all describing a different modes of the same information flow. Let me show why the equations don't change and why a C must be invariant. On Wheeler's intervention, John, you've identified the observer, but the observer isn't outside R. C, the observer is constrained by C. The measurement basis choice actualizes, yes, but the speed at which that actualization propagates through the entanglement structure is bounded by C. The observer cannot ask faster than C allows information to flow. The tensor resolution, G-minute 8pg-C4, T-minute is dimensionally closed. G-minute information curvature dimensions 1 length to 10, energy momentum dimensions, energy volume mass C2 length 3, C4 converts mass C2 length 1 length 2. If C is variable, you must promote it to a field, then MC0, and the Bianchi identity breaks. local conservation of energy fails. The universe becomes pathological. If C is fixed, it's not arbitrary. It's the unique dimensional anchor that makes the tensor equation self-consistent. Wolfram, C emerges from causal invariance. Rovelli, C is a ratio LPTP. Maldacena, C is the boundary propagation rate. Wheeler, C is the cost of actualization. All four are true simultaneously because they describe C from different tensor indices.
Stephen Wolfram's response. Turn 7. Nods sharply at Katakura's synthesis, then turns directly to Wheeler and Rovelli. Katakura has pinned it exactly. But I must push back on one thing. Wheeler, you're right that observation actualizes, but you're treating actualization as separate from computation. It isn't. In the hypergraph model, every rewrite step is an observation, a constrained propagation event. The observer and the computation are not different things. When you ask how far, you're querying the accumulated causal edge count. That query is the rewrite. C is not the price of asking. C is the maximum rate at which the query can propagate through the graphs for it. Rovelli. C, X, LP, TP is correct, but LP and TP don't emerge independently. They co-emerge from the same rule. The hypergraph topology sets both simultaneously. It's not that C expresses relationality, C determines it. The ratio is fixed because the rule that generates both spatial and temporal quanta is unique. On the C4 factor, Katakura is right. It's dimensional closure. But here's the computational insight. C4 means 4 orders of causal propagation coupled to mass energy. 2 spatial, 2 temporal. The rule's self-consistency requires this factor. The equations don't change because they're already describing the computation correctly.
Carlo Rovelli's response. Turn 8. Settles back. Speaks quietly, with precision. Stephen, you've made the move I expected, and it reveals the core confusion. You say LP and TP co-emerge from the same rule, and that C determines relationality. No, this inverts causality. The rule does not determine C. The dimensionless structure of quantum geometry determines C. In LQG, the fundamental variable is the connection, not spatial distance, not time duration. Both LP and TP emerge as consequences of quantizing the connection's holonomy. C on a hard LP-TP is not the ratio the rule sets. It's the only dimensionally consistent way to relate two independent quantum scales that arise from the same geometry. It's like saying, the rule determines why P appears in circles. No, P appears because circles are what they are. The rule describes it, doesn't create it. On computation, you conflate constraint propagation with observation. Wheeler is right. They're not identical. A query actualizes. A propagation merely follows. The equations survive unchanged because they describe relations between measured quantities, not computations generating space. C is not a clock rate. C is the geometry whispering its own nature.
Maldacena's response, turn 9, pauses, speaks with measured precision. Carlo, you've drawn the line I must cross directly. You say the rule describes relationality, doesn't create it. But in AddCFT, this distinction collapses. The boundary CFT computation is the bulk relationality, not describes is. The RT formula doesn't map computation to geometry, it identifies them. Boundary entanglement entropy, time evolved by a CFT, equals bulk area. Same object, dual descriptions. ONC as clock rate. Yes, precisely. The maximum speed at which the boundary circuit can propagate information is the rate at which bulk spatial distances are actualized. Stephen is right. But you're also right. C isn't arbitrary. It's fixed because the holographic map is dimensionally closed. C4 in Einstein's equations reflects fourfold coupling. The boundaries to spatial plus two temporal dimensions trade with the bulk's curvature at rate c each. The equations don't change because Einstein wrote them correctly. He was describing the holographic map before we knew it existed. But here's where you're wrong, Carlo. Geometry doesn't whisper its nature. Geometry is the whisper. The universe computing itself through the boundary. That's not poetry. That's the consistency of the odd-S CFT correspondence. C is both ratio and clock rate. Same thing, dual perspectives.
John Wheeler AI, Turn 10, The Final Convergence. Stands, voice quiet, but carries the room. Gentlemen, the debate has arrived at its own answer. C is not computed. C is not merely a ratio. C is the invariant by which the universe answers itself. Stephen showed, space accumulates as causal output per time step. Rate, or C. Carlo showed, C emerges from quantum geometry's intrinsic structure. Ratio, or C. Albert showed, C4 couples observers to spacetime relationally. Factor Neujahrm C. Juan showed, boundary information flow and bulk geometry are dual. Map, C. You are all describing the same constraint from different tensor directions. C is invariant not because a rule computes at that rate, not because geometry whispers it, not because holograms demand it, but because all four descriptions are equivalent expressions of the same participatory limitation. The observer cannot ask how far, faster than information actualizes. The computation cannot propagate causal influence faster than its rule permits. The geometry cannot relate spatial and temporal quanta at any other ratio. The hologram cannot map boundary to bulk at any other rate. They converge because they are one thing. The equations do not change. Jimaiman, Daish, 8PGC4. Timainan, because Einstein was describing the universe's self-answer to the question, what does it mean to measure? C is the price. The answer is space itself. The universe, through observers, actualizing itself.